In this video, I'm introducing the brain simulator's new ability to operate a spiking neural network distributed across multiple computers. If you have a number of computers connected by a private network, I encourage you to try out the multi-computer configuration. In a previous video, I calculated the number of computers needed to emulate the human neocortex's 16 billion neurons. Running the brain simulator across multiple computers is an important milestone toward reaching this objective. In operation, things couldn't be easier. When you create a neuron array, the brain simulator still defaults to running on the local machine, but if you simply check Use Servers, the system will query available neuron servers on the local subnet. Neuron servers are just apps, so starting them just requires starting the app on each server machine. Here we'll start 3 servers. A quick refresh, and the neurons are distributed across the servers. You can override the neuron distribution if you like. Pressing OK creates the spiking neural network. The fact that it is distributed across the servers is completely transparent. For illustration, I've created a tiny network. The neurons in each column are running on different physical machines. I can add and delete synapses between the neurons and see neuron status as if they were all running locally. Each neuron server continuously displays the current generation number of firing neurons, the number of synapses which cross the machine boundaries, and some timing information for performance tuning. This server represents the left column, and you can see it count a single firing if any neuron in the left column fires. You can also see the boundary synapse count when the upper left neuron fires, sending a spike to the neuron in the center column, which is on a different server. For a larger demonstration, here is a network of 1 million neurons and 10 million random synapses running on a single server. It processes each firing generation in about 90 milliseconds. Here's the server display. Note that because it's a single server, there are no boundary synapses, and the transfer time for those is 0. Here's a similar network with 20 million random synapses running on 2 servers. It processes each firing generation in about 100 milliseconds. Note that there are over 10,000 boundary synapses. Here is one running 30 million random synapses on 3 servers, running at about 110 milliseconds per cycle. As servers are added to create a bigger network, speed is more or less constant because the number of boundary synapses on each server does not significantly increase. Looking at Ethernet performance, you can see that network traffic represents less than 1% of the network's 1 gigabit capacity. This initial test demonstrates absolutely that adding servers can dramatically increase the capacity of the network. In the next video, and in a paper I'm writing, I'll present some technical details, along with ideas about how performance can be significantly increased. Then I make projections about how networks will scale with a biologically plausible distribution of synapse connections. Once again, I encourage you to load the source code and try out the brain simulator in a multiple computer configuration. And please like, subscribe, and comment. And as always, thanks for watching.